Hello guys, so in this video we will be solving the Leetcode question number 226, invert binary tree. So you are given the root of a binary tree, invert the tree and the return its root. So here you can see you will be given one binary tree. You need to create the image of that binary tree, that means invert of that binary tree, and you need to return the root of that tree. So there are two approaches to solve this problem. The first one is you can create the new binary tree and you do the all processing, then return back that newly created binary tree. But creating a tree is a costly process. So what you can do is you can do the in-place swapping operations in the given binary tree itself, and you can return the root of the original binary tree itself. So that was the best option you can do. So first I will explain the logic behind the solution, like how to proceed with this question. So so 4 is the root of the tree, then you have 2 on the left side and 7 on the left side. So then from 2 we have on the left 1 3. So as of now I'm not writing the 6 and 9 just for the time being. So now what we can do is from the root we go to the left subtree, and then from 2 we will go to the left again 1. So here we don't have any left and right, so we will return this 1 to the parent. Then now we will go to the right side part 3. So 3 again, 3 is the leaf node, so there is no need to process further, so we will return back that 3 node to the parent node. Now again we will create a new, here we do the swapping part. So for from the parent we do the swap, so we will take the put 3 here and 1 here, then this side 7, so and 6 9. Yeah, so now we swapped in the leftmost subtree. Now from here to this node it will return to the parent 2. Now we process the left side, now we will see the right side. So now go to the right side of the subtree. Now again 7, so from 7 go to left, so 6. So from 6 we don't have any further, so you don't need to move further, you just return that 6 node. Now go to this side 9, so 9 is the leaf node, so then return that 9 node. Now you do this swapping at parent 7 root node, so this will become 4 2 3 1 and 7 9 6. Yeah. So in this case it is written this second node and it is returning this node. So now at the root level, now 4 is the parent for the 2 and 7 nodes, so now we swap at the root level. So now 4 become 4 is the root, and now this 7 will come this side, the pointer itself, and the 4 and the 2 goes to that side swapping, so it will be 3 1. So if we see, we have the root level 4, then 7 2, then 9 6 3 1. Yeah, so we created the invert binary tree from the original tree. So that's how it done. Now here you can see how we are doing the swapping part. So while returning at the root node, we are taking a left pointer and making a copy it in the temporary variable, and then from the root node left pointer is changing to the right pointer, and the right pointer is changing to the temporary variable that we stored the left side pointer address. So that's how we create the invert binary tree. Now we will write the code in Python and Java. Now let's write code in the Java. Okay, first if root equal to null, then just return null. Now we supposed to call recursive calls. First we need to process the left side, then we'll come to the right side, then we swap it. So first invert tree root dot left, we go to the left, then invert tree root dot right. So now then we go to the right. Now we store the current node. So it's a tree node temp equal to so root dot left. We are storing the root dot left. We are creating a new node and we are storing the pointer of that root dot left in the temporary. Now we update the left side. Temp dot left equal to root dot right. Now root dot right equal to sorry not temp root dot left. Yeah, now root dot right equal to temp. So the left and right positions are swapped. Now return the root. That's it. Run the code. Yeah. Submit. So it's successfully submitted. Now we will write in Python also. Now let's write code in Python. If not root, just return none. Now you need to process the left side of the tree. Invert tree root dot left. Now you should process the right side also. Invert tree root dot right. So once it reads back to the parent, we do the swapping at the parent level. So now we have to store the left pointer of the root dot left. Now update the root dot right equal to root dot. So we have to update the root dot left first equal to root dot right. Now root dot right equal to temp. Now return the root node. Now run the solution. Invert. So it's accepted. So yeah, that's it for this video guys. I will see you in the next video.